Oh, good. You can hear me. That's great. Nice to see so many of you here. Well, mostly see. I'm Anna, as Zara said. I am the Senior Manager for Cloud Platforms and SRE Engineers at Vodafone UK. And for those of you who don't really know what that title means, I am leading the cloud engineering and SRE engineers in Vodafone. Those are the people who are actually working in keeping our systems up, always for you as customers. I've got over 3 years experience in leadership, and I've previously worked as software engineers. So I do understand all the engineering challenges and bringing that into the SRE world. As I mentioned, leading the cloud platforms engineering, we are sitting within the wider digital department in Vodafone, and we are working closely with a lot of other departments to make sure, as customers, you come on our platforms and you actually have a great experience. I'm also a customer of Vodafone, so that's actually why I'm working at Vodafone, so I can have that great experience bring to the customers like me. Before we go into how we actually support those systems, I wanted to give you a glimpse of what those systems are. And in Vodafone, hopefully some of you are customers, you probably will use the website or the application. But you might also go in our stores. So our colleagues in stores also use products that we build in-house. And those products are integrating with systems that we also support. The Vodafone data centers, where a lot of our customer data is stored. We also make sure that our systems integrate with the data center and it is up and running. So we need to collaborate with our colleagues to understand if they're going to support all those peak traffics or any other kind of events. Our customers at customer call centers also use systems integrated within the same system. So we need to make sure they also have a great experience. Not only that we offer you as customers on the website a great experience, but if you do have an issue and you call our colleagues, they also can support you. My Vodafone app, hopefully you've got to download if you're a customer, is the greatest way to interact with our product, also buy products, also check your spending or plans and so on. And my Vodafone website where you can find all the other information while you're also buying our products. All these systems are interconnected together, and this is just a glimpse of what we have. And our SRE engineers are the ones who are supporting these systems. They work with our colleagues in different departments, like data centers, to ensure that all these connectivities are working. But all these systems are underpinned by our core product, which is the network. So I mentioned SRE engineers, but what are they? So site reliability engineers, they are the engineers who are focusing on the scalability and stability and reliability of our services. They have 5 areas of focus. Those areas are collaboration. As I mentioned, lots of systems we have. It will not go smoothly if we don't collaborate. So our engineers have a lot of collaboration going on between different departments. Not only the technical departments, our business departments are supporting us, understanding what comes up for us. The next area is the product service ownership. It is great to own and make sure the system is running, and we have lots of teams that are building those systems. But in order to ensure that scale of observability, of support for our systems, our cloud engineers are developing products to be able to reuse across all our teams. And those products is what they own, making sure they are reusable, they are supporting our engineers, and they do actually make sense and they're easy to use for our engineers. Proposition delivery. When it comes to product launch, it's all about how we make sure that new product or new feature is actually supported and it does not impact the rest of the features we have live. For that reason, we are involved in the proposition delivery, in the whole life cycle of a new proposition, from initial ideation to actually delivering and monitoring and supporting production. Quality and security is very important for us. It is quite a big domain we are looking after, with sometimes what we think is a small team. But of course, quality and security cannot be overseen. So what we are doing is we're developing products that will support us in how we embedded quality and security gates within the life cycle of delivering product. So what our engineers are doing is building those products they are owning and working with our software engineers in embedding them in the life cycle. They do add those products in CI/CD pipelines, so where we are delivering our code. They also add those products in just how they create a new service, whether it's automatically creating dashboards in Datadog or anything else that is required to make sure our quality and security is not underseen. And everyone, even if they might not have the knowledge at the beginning, our junior engineers, they have all those gates embedded. Resiliency and problem solving is a very important area of focus for our SRE engineers. And in this area, what they're focusing on is really how we can support engineers and businesses to come together and resolve those problems for our customers. So for that reason, we have a lot of tooling, but also we have great minds. Some of them are actually here. Thanks for joining me. And they are looking in problem solving, how they actually think about solving a problem at scale. And to help our SRE engineers with doing all that amazing work, what they use is a lot of toolings. This is just a glimpse of them. We do use Azure DevOps for our code repositories and our dashboard and how we manage the whole project delivery. We use GitHub to build reusable code that is shared across our global organization. While our engineers are building from UK, maybe, they can share with other organizations, other markets we work with. And I'm hoping you recognize the logo. We use Datadog. We use Datadog for all our observability, monitoring, ensuring we get all those insights from the services in the whole journey. And I'm glad I've seen earlier speaking about all those life cycles in a journey from code to production. We use it in all those cycles to make sure we not only know how our code is actually behaving in production, but also how we are doing before we go in production in the non-prod environments. We are using it for a lot of the testing to monitor all those environments and understand how our services are actually behaving in integration with other services. And we are using PagerDuty to understand what's happening live. So all our monitoring from Datadog is integrating and triggering alerts in PagerDuty, which our SREs are picking up and analyzing. We do use that also for non-prod, not just production. We want to make sure if something goes wrong through our life cycle, we actually know before we arrive in production. So our engineers are always on call and understand that. And we use Terraform. As I mentioned, Vodafone is quite big, large scale. In order to make sure we have consistency across everything, we use Terraform for our infrastructure as code. So all our infrastructure is being built in Terraform. And observability as code. I'll give you an example later on of what that looks like. But with Terraform, we ensure the consistency of observability between all our services, and we also make sure that our engineers can reuse without a lot of hassle and effort. Within digital engineering, mostly we are using AWS and Azure. We do use other cloud providers, but those are the main ones we are focusing on within digital engineering. You've seen a glimpse. We are going to look into 2 different traffic patterns that our engineers are supporting, and I will tell you more about how we actually prepare for those. So one of it is just a normal scale. We have a new launch or a new campaign maybe. Our customers come on all our services, whether it's My Vodafone app or the website. And they actually want to make sure they have the same experience, they have the same availability of our services across these applications. Now, what we see is an increase in traffic, and you can see the yellow line there. It's the week before the event, and the blue one is the week of the event. So you can see it's doubling the traffic. Well, this is great. What our SRE engineers need to do is at the time of the event, not much, because they are preparing in advance. So all this is handled by autoscaling. And we build this with those products that we are sharing with our engineers. We build autoscaling in. So whether it's serverless functions, we don't need to worry about that. AWS does worry about that. Or whether it's other Kubernetes clusters, we have all that scaling built in, which means our SREs don't need to do much other than just have their pager with them, just in case, and all that has been handled. Great, so why do we need SREs then? Well, we do have another traffic pattern, and this one is where we put lots of preparations in. We have some of our products that are very, very popular, and when they go live, we see an increase of 20 times our traffic, our normal traffic, within seconds. Now, autoscaling is not going to be able to help here because it can't do that job within seconds. But our customers can't see the website going down or the services being affected. Or our customers in store. They should not be impacted by the traffic we get on our website. So for that reason, we have lots of preparation and lots of collaboration. What we do in these cases is we do look at a lot of data from our past events that helps us to understand what is the traffic pattern we expect. Great, but it's not just data. We collaborate with our business partners. We understand from our proposition departments what do they expect in terms of orders or traffic for this new product that we're going to launch. And for that reason, we have a lot of data collected, so we understand how we want our service to behave in that moment. It's good to have data, and it's good to understand what you need to do. But how do you actually do it? We have a lot of performance testing. What that is we get all this data, and we look at our services, and we understand the scale they need to run at, and we test it. And we test that through performance services. We build in-house some services, some products that will support us to mimic the traffic pattern and understand how our service behaves. And we can look at different services and say, at this performance testing, this service, this period, that's how it behaves. It needs more resources, or it doesn't. It just needs to be more balanced, maybe. So all that, we looked into the dashboards in Datadog to understand how those services behave. When we create our services, I mentioned earlier, we have some products that will automatically create these dashboards for performance. So our engineers don't need to worry. They just need to go on Datadog and check it out. And because it's not just about the data of scaling, it's very important for us to make sure we don't scale above what we really need. And for that reason, we want to build a culture of FinOps in our engineers. And for that reason, we added the cost of the infrastructure within this dashboard. So they are aware of how much it costs us to scale at that size. And they make conscious decisions about, informed decisions about what they need to do to support the traffic and support the business, while also being conscious of the cost of doing that. And performance testing is great. It gives us exactly what we need. But we also need to make sure we are always prepared, not just in those big events. And for that reason, we use a lot of other features from Datadog. We have red dashboards. For those who don't know, it's like rate, error, duration dashboards where we analyze our services, but also APM quite a lot. So hopefully you use it. It's great. It analyzes everything. But APM, what really allows us to do is track that service beyond just its remit. It is a distributed architecture we have, a lot of microservices. We can't just look at one service individually. We need to understand how it works in the environment it is deployed in. So for that reason, we use APM to understand how it integrates. And I was telling you about observability as code. When our engineers are creating services, they automatically come with some metrics. We consider them as the basic metrics you should have for all the services. Those metrics are automatically added to any new service that's been created. In this example, you've got 4xx and 5xx traffic for our APIs. Our engineers should not care about the basic metrics because it's a common sense you'll have them. What we want them to focus on is really on the custom ones from their services. So what they can do is, using Terraform, you have the core metrics, just expand them and add the ones you need. And for that reasons, we use Terraform to allow our engineers to do that. Having all this added in the CI/CD pipelines, it supports our engineers to make sure everything is built through the whole workflow of the product. And from testing it, making sure they have those observability also in non-production, they look at the service before they go live, they have quality gates, which means we run this, we check it. If it doesn't pass the quality gate, does not go to production, does not affect our customers. If it does, go to production, continuous integration and deployment. Great. And of course, all this is available for all our engineers, which means we have consistency across all our services. We wouldn't have been gone here without a lot of focus on learning. And this is where I think is very important. It's great to have tools like Datadog to support you. It's important what you do with them. What we've focused on is a culture of psychological safety, where our engineers, and not only everyone in the business, is encouraged to give feedback and support with feedback. What that will allow us is to improve on what we already built. Looking back at historic data, it supports us to build the next, to be prepared for the next event and build the next feature. It supports us to understand what's missing, what else is to be done. It was mentioned earlier about looking back at the events and issues and postmortems, maybe to look into how to learn and build the next feature. We are doing that. We are encouraging everyone to learn. And yeah, I've seen the AI agents, definitely something we want to try out and see how we can learn from those. And then we are also learning from our success. I mentioned the cost of scaling. It is a cost that the business needs to pay. It's a cost that supports our customers to not have issues, but it is a cost at the end. So learning from those successes and looking at optimization is something very important for us. Addressing challenges. Sometimes we understand, especially when we have those big events, we understand there are some challenges maybe with our infrastructure or some service within our wider services. So we look at that with our architecture teams maybe or other engineers and understand how can we make this auto-scale maybe next time, or how can we make it prepared for those kind of scaling. And we are looking into how we can evolve our infrastructure. So by fostering continuous improvement culture, we are supporting our engineers, we ensure our customers don't have any issues, and we use tools like Datadog to get us through that journey. I think that's it. Well, come later to ask me any questions if you have, but hopefully you got some good tips to what to try. Thank you.